Hello there everyone, my name is Matthew Koger, and today I'm going to be talking about the Linux graphics stack, specifically about X11, its replacement Wayland, and how it'll be affecting you. Now, before we begin, let's motivate this question. What challenges arise when we're implementing a GUI desktop environment? Something like GC on Windows or Mac, or if you're using GNOME or KDE, or anything of that sort on Linux. And two challenges came to mind for me. The first is that it's really hard to have multiple GUI programs properly filter inputs. What do I mean by this? Well, for example, how do Windows communicate which is in focus? You can't have all of them, accepting each and every keystroke image. Secondly is who manages things like global macros. I'm sure we all use those quite a bit. And the second concern that came to mind is how do you actually even render these multiple GUI programs all at once? Working with the GPU directory is racy and device dependent. It's just not going to work if every program is directly accessing your video card. Now, Linux's kernel does have a subsystem called the Direct Rendering Manager, or DRM, and it mostly solves some of these issues. However, several operations can only be done by a single user space process, so it's not really getting rid of the raciness, and some device dependence still exists. So, with that all in mind, the modern solution is something called a display server, and it solves these issues by having GUI programs communicate with the server via IPC as clients. The server then coordinates its client's inputs and outputs. So it's a monolithic solution to the problem that looks something like this. It sits right between the actual GUI and the kernel. And there are plenty of examples of things like this. macOS has one called the Quotes Compositor. Android uses something called Surface Furner. And Windows, actually that's a bad example. We know Windows uses something, but it's all hidden, so who knows what it's called. For Linux, we have the X11 display server protocol. Now, if you're wondering what I mean by a protocol, then it's very simple. Unlike Quotes and Surface Furner, X11 is not a full display server, it's just a specification. So, there have actually been a number of implementations of an X11 display server. Xquotes runs on top of the Quotes Compositor for Mac. Windows has a bunch of them, Sovereign X, VCXserve, and Xmin, were the ones I found. And we're going to ignore all of those and focus on what runs on Linux. Now, I would love to go over the actual X protocol here. However, as you can see, it's pretty massive. It keeps going on and on for about 160 pages. Now, keeping that all in mind, let's look at a high-level view of X11. It's actually very simple. So, events start when the kernel picks one up, usually through the EVDev driver, and it sends it to the X server. The X server then guesses which window the event affects and sends it to that Windows client. Now, if you're wondering why it has to guess it, that's because of that box there called the compositor. A compositor is the program responsible for rendering the entire screen's content. Quite a big job. The way it works is that the X lines are stored in a scene graph, so that tells you where the various windows are. Each window has an off-screen buffer that it's rendered to. The compositor then composites these buffers into a single image representing the screen. And the problem is that last step can do anything. It can put them all in a giant 3D box. It can distort them. When you close the window, it can add a file effect. And the end result is that particularly wonky compositors mean that the X server doesn't quite know where things might be. That being said, I've personally never had an issue with it, and I'm not aware of anyone else who has. So whatever code it uses is pretty good. Regardless, the client gets the event and processes it, so it has to update the UI somehow. The example I see most often is a checkbox being clicked, and in that case, the client sends a rendering request. The X server then receives that rendering request. It does some stuff with the driver to get ready for rendering, and calculates the area of what changed. It then sends that information to the compositor via a damage event. The compositor then tells itself what it needs to redraws everything, and sends that back to the X server, which then displays the new screen. Now, that seems perfectly fine, right? Yeah, X has a few problems. The first of which is that it's old. How old are we talking about? Well, the current implementation of X, the X server, was created in April of 2004, and itself was for X386, the previous implementation, which imploded due to, among other things, licensing disputes. X386 dates all the way back to September of 1992, where it was a fork of the X386 server, very clever pun, a 1991 X1105 server for IBM compatible PCs, which was donated to the MIT X Consortium by Snidder Graphics Consulting. Now, these weren't even the very first X servers. They've been around even longer since the protocol was created by these two guys, Jim Dennis and Bob Schieffer. Now, Mr. Schieffer did not have a photograph on his Wikipedia page. However, since people with the same name or similar names always must look similar, I found a suitable visual substitute. Regardless, they created the server in 1984, 7 years before the X386 server. So there's quite a bit of history here. And in fact, some people believe that the first X servers were even earlier, some speculating all the way back to the Crimean War. The point of this is, the current server is full of legacy code. Now, the second issue with the X protocol is that it is incredibly complicated. It has a lot of functionality that nobody uses. The most common example I see is the fonts. So the original had a font model, That includes things like code tables, drift rasterization, and XLFDs. Now, I don't even know what an XLFD is, and from what I can tell, everything here is ancient stuff from the 80s and 90s that no longer needs to be done by the server. Another example of that is the rendering API. There's an API built into X11 for rendering everything, and it has cool things built into it, like lines, arcs, polygons, and plenty of other graphics primitives that you will only see inside a cyberpunk game. And of course, there is yet more. Third of all is that X11 is surprisingly restrictive. There's a lot of stuff that is surprisingly limited. For example, that rendering API, you cannot bypass it. If a client wants to render something that it created, it has to pass it to the X server as a pixmap, a raw bitmap. And as I'm sure you can guess, that is awful for 3D graphics. X also has an issue with different DPI scaling on different monitors. In fact, it has a lot of issues with pixels in general. And it has a major security issue wherein any X program can effectively have unlimited access to the contents of another X client window. And as a bonus problem, X11 allows screen tearing, bad screen tearing. I'm sure you've all seen this image. It's the top result if you search for screen tearing. And it is something I can testify from personal experience I've had to deal with all the time. And unfortunately, it's just a fault built into the X server. So, clearly there's a lot that can be fixed with X. Big question is, how do we fix it? The general consensus that has emerged is that X needs to be replaced, and the current candidate is something called Wayland. It's the new challenger. Now, before I go any further, I need to say that Wayland isn't really new. It started out all the way back in September 2008, so 9 years ago. It was created by this guy, Christian Hertzberg, who, again, I did not see a great photo of on Wikipedia, and Google searching got me photos of multiple different people. However, I do know that he is Danish, so I assume he looks something like this. But regardless, he was an excellent developer, and all of the current developers are also mostly excellent developers. I mean, even the name Wayland isn't new. It's named after Wayland, Massachusetts, a positively antediluvian town in the foothills of Arkham. Regardless of how new Wayland is, it does a number of things differently than X. For one, compositing is built into the display server. It's no longer a separate program. This has the nice side benefit of removing screen tearing, so I already like it. Another change is that the whole rendering API has been done away with in favor of something called direct rendering. This is the replacement for server-side rendering. And basically what happens is the client and the server share a video memory buffer. The client then renders directly into the buffer. It can do this a couple of different ways, and Wayland's test tracks use 3 different ones. They rendered via software and Cairo, a graphics library. They use Cairo on top of OpenGL, or they just use hardware-accelerated OpenGL directory, and the server then uses the buffer as a texture when compositing. So this has a nice bonus of meaning that we can get rid of a lot of that bloated functionality and move it to where it belongs, various different libraries. Moreover, trying to now more securely isolated. Now, looking at things from a high level again, we get a picture fairly similar to X11. The kernel picks up events and sends it to the compiler just as before. The compiler server then looks through its email and this time accurately determines which window receives the event. The client window then processes things just as before, although now it does the rendering on its own. The compiler then recomposites and displays the screen. Now, the client rendering is very different than under X, but it's actually not a problem for most programs. This is because GUI toolkits like GT5, GTK3, Tartar, STL, and EFL all have Wayland versions. And if you're running a truly legacy X application, it can use something called X Wayland, which is a miniature X server that runs within Wayland. Moreover, many major desktop environments also support Wayland. Mother and Tailwind, which are the compilers of GNOME and KDE, so the 2 biggest desktop environments out there, have been rewritten as Wayland servers. And while a number of smaller compilers have not, there are a lot of libraries like wlroots and wlroots that should allow others to follow suit fairly quickly. So with that in mind, that sounds pretty good. So why haven't we switched over yet? Most unfortunately, Wayland does have a few problems. The first is basically by design. It's a very minimal system, and as such, a lot of features that are built into X11 that we do use are out of scope for Wayland. Many automation features, for example, simply don't exist. You want to have global hotkeys. The Wayland server doesn't know what they are. You want to use something like Xtutor. Sorry, that's going to break. This extends to a bunch of accessibility features that are also just out of scope. Want to have a color correction system? Wayland doesn't know what that is. Want to have hover to click? Again, nope, not going to work. Oh, here's another one. Want to play a video game through Line? Sorry, that's only going to work through X Wayland. Number of features it uses just aren't in Wayland proper. Similarly, if you want to drag a file into your web browser, something a lot of website sites have to do, that's not part of Wayland either. If you want to do a screen capture, just like this video, not supported, goes directly against the isolation of the various clients. And if you want to use a Wayland machine remotely, that's going to be a problem. There isn't an SSH-X analog. If you want to have any of these work, It is up to the individual composers to implement these extensions. Now, I'm sorry if that came off as a tad gloomy, because there really isn't too much need to panic here. People at GNOME and KDE have a lot of these solved. They all know that a desktop needs a lot of these features and can't go without them. Moreover, there's libraries like wlroots that I mentioned are similarly working on them, and that should save all of the smaller composers from having to reinvent the wheel. Now, it is a matter then of simply formalizing these extensions protocols. Mostly. There is one area you may want to panic about, and that's networking. Networking is, well, it's actually quite a bit of a mess. There is very little information out there on it, and all I've been able to find are some examples of how you might get Wayland network aware. They are mostly proof of concept. So far I've only seen them in GNOME, and on top of all this, I can't find anything about how Wayland will interact with X systems over the network. Unfortunately, Wayland actually has even more problems than just these scoping issues, and to get to the heart of those, let's look at a more in-depth diagram of how the Wayland graphics stack works. Now, luckily we can ignore almost all of this diagram, as you can see it's a lot more in-depth than the one we looked at before, and we're going to focus on those few green lines that are labeled EGL. Now, what is EGL? EGL is an X-independent interface for OpenGL. Wayland and most of the Wayland clients, as they've been implemented, use it to draw directly to their shared graphics buffers. And these buffers, in turn, are created with something called Generic Buffer Management, or GBM, which is an API for allocating graphics buffers. Now, to be technically correct, GBM creates a handler to initialize an EGL context, which then is used to initialize OpenGL ES. Even that's still just a high-level rendition of what's actually going on. We could spend months going over how the OpenGL stack works. However, the gist of it is that it depends on GBM, and GBM sits right on top of the DRM subsystem. It abstracts most driver-specific buffer management APIs. Now, I can already hear what you're thinking. Wait, most? Who doesn't play well with it? And the answer is, unfortunately, NVIDIA. Wayland has major difficulty running on anything with an NVIDIA graphics card, so most desktop computers. GBM simply doesn't work with NVIDIA's proprietary drivers. In fact, when NVIDIA went to implement their drivers, it took an entirely different code path, which they summarized as requiring EGL device, EGL output, and EGLStream objects. Unfortunately for all of us, no other graphics cards support these EGLStreams objects. Now, if you're at all like me, your first thought to realize that that's unfortunate but not insurmountable. I mean, 2 code paths isn't too bad for graphics software, right? Unfortunately, EGLStreams has seen, let's call it, lackluster adoption. GNOME, in fact, did implement it, specifically the Red Hat people patched module to support it. However, KDE has not, and they won't be patching Wayland unless NVIDIA themselves submits and supports the patch. As they put it, they just don't have the resources to maintain this session code path, which I can understand. So, that covers the two big desktop environments. What about the smaller ones? As we mentioned, they're likely to have to use a library like wlroots. And wlroots will not support EGLStreams ever. It's not a matter of practicality here, but rather, well, I'll let the maintainer speak for himself. Now, in full disclosure, I am one of those NVIDIA consumers. I've used the NVIDIA card for as long as I can remember, so this issue in particular is one that I am somewhat biased on. It's very important to me because I would one day like to be able to use Wayland. With that in mind, I can say, don't panic. NVIDIA and the various other people involved are working on a replacement for both GBM and EGLStreams. They made some good progress back at the X Developer Conference 2016. Unfortunately, progress is slow. So perhaps the best way to summarize how you should feel is impatient, because you really only have a few rather lackluster options in the meantime. First off, you can use the open source Nouveau drivers for NVIDIA cards. They do support GBM. Unfortunately, they're just less performant than the proprietary drivers. I personally have used both the Nouveau drivers and NVIDIA's proprietary ones, and I can say from personal experience that the proprietary ones are simply better to use. Now, if you don't want to get into the issues of drivers, you could always just buy an AMD card that should get you support for GBM, and once upon a time, that was a viable option. Unfortunately, recently, you may have heard of this phenomenon known as Bitcoin and cryptocurrency in general, and if you ever want to mine that, that is entirely dependent on having a bunch of very good graphics cards. So really, if you want to switch cards now, all you can really do is hope that you outbid the crypto miner for an AMD card. It is rather expensive now. So, let's recap. X11 and X are really ripe for replacement, and Wayland is what's probably going to replace it. Wayland is a minimal display server, and it is in many ways very nice. At the same time, however, it's not quite ready. There are a number of extensions to the protocol that just aren't done yet. And on top of that, the vast majority of users, which is to say people who have NVIDIA cards, really can't run Wayland, at least not in a satisfactory manner. That being said, in the near term, you can expect some things to break. This is because many distros are switching over to Wayland anyway, Ubuntu has switched over for its non-LTS releases. Debian is about to switch over. Fedora switched over some time ago. OpenSUSE will be switching over. In fact, I believe the only major distribution that isn't is Linux Mint. With our demand, a lot of those not quite ready extensions will show up as you use your system. Things like the clipboard may not quite act like you expect it to. It shouldn't be anything earth-shattering, but it will likely be noticeable. And again, as I said, if you want to use these systems remotely, it's going to be a mess for a little while. That being said, do not be mistaken on the way things are going. A lot of time has been spent getting Wayland ready. Wayland is going to happen. The only question is when, and that's unfortunately not something I or anybody can answer. Having said that, let's all guess. Let's look at how Wayland's future may play out, viewed through the lens of Ubuntu releases. I speculate that for the next LTS 2004, which I hope will be called Flowing Falcon, it will have Wayland as an almost default. What do I mean by that? I'm not sure, but it will be more privileged than it is now. Ubuntu 2110, which I really like to be called Linux Atlanta, will probably see a Wayland server with the replacement for GBM and EGLStreams, so it will likely run for everybody. Ubuntu 2204 LTS, which really should be named Jealous Jellyfish, will likely have Wayland as the absolute default. And 5 years after that, with 2704, which I think should be named Trendy Tanuki, then I speculate the actual server will not be shipped by default anymore. Nothing beyond X Wayland. Do I have any reason to believe these will come to pass as I've described it? No. Now, if you want to read more about this, I've compiled a giant list of articles that I've found, mostly assorted in web pages on X and Wayland, X's issues, Wayland's missing features, what skill sorter I can find on Wayland and networking, EGLStreams, KDE and wlroots on EGLStreams. And I also have a list of a number of compilers that use Wayland if you want to see what it looks like. Thank you.